Good evening, everybody. Welcome to Chem 1211 with your host, me, Dr. White. Boy, where did this semester go? Where did this summer go? It's the end of summer semester. Next week will be the last week. And I should tell you something personal. Uh, I've decided to retire, so this is my last class. I'll be teaching at COD. I also am retiring from Elgin Community College. It's about that time for me to have some fun and do some other things in chemistry besides teaching. I still consult. All right, let's go to Blackboard. And I'll move this to be the lead. I'll do it right now. All right, let's talk about coming up this Saturday, tomorrow, and next week, Monday, Tuesday, and Wednesday. You will be taking test number 2 and the final exam, which is a standardized American Chemical Society multiple choice final exam. You need to take it at the Glen Ellen Testing Center. That's the only place you can take these. You have from Saturday the 2nd, they're not open on Sunday, then Monday, Tuesday, and Wednesday to take test 2 and the final exam. Now, due to heavy volume at the end of the week, end of the semester, finals week, which we really don't have in the summer, but it's the last week, I strongly urge you to take the test number 2, then the final exam right after you take test number 2, either in the morning, tomorrow, Saturday, or on Monday or Tuesday. Now, the test center has a procedure that if you have a 2-hour window for, say, an exam, and you get there an hour before they close, even if you don't need the 2 hours, they will not allow you to start that exam. So that's why I'd say get there in the morning or early afternoon. Now, I highly recommend that you take the final, and the ACS final means the American Chemical Society final exam. I'll talk about that in a second. Right after you take test number 2. Don't take the final first. I'll explain why in a little while. But when you're at the desk to get your test 2, tell that person you're going to take the final right afterward for Chem 1211. The reason why is then you don't have to get back in line. Just go back to the desk and they'll give you the other thing, let you get going. Now, I would highly recommend you watch these 2 videos. All right, let's talk about test number 2, which is really my final that I'm not allowed to give, so I call it a test. And you'll be given up to 2 hours. Most students are done in 60 minutes or less, so I'm giving you plenty of extra time. Remember, at the testing center, you have to have a picture ID and bring a scientific, non-programmable, that's the one not with the big window, but like something like this would be fine, like I've used all semester with you. I'd highly recommend bring pencils and bring these type of nicer erasers. And test number 2 will cover the whole semester. It has 25 problems, 8 pages. There are 3 multiple choice, and some of the questions are multiple part. Now, the point breakdown on test 2, 12 points come from the material quiz 1 and 2. 38 points, yes, 38 points come from test 1 material that was covered for test 1. 25 points to quiz 3 and 4, and 22 points quiz 5 and 6, which hopefully you finish or will finish by 11:30 tonight, p.m. tonight. And then new material, which will be with radioactive material and things like that. Now, for this my test, remember to please use significant figures for all calculated answers, and please use 3 significant figures for all atomic masses. Now, let's talk about the final exam. And this is required by all students taking, this is about every chemistry class except 1105. They have for the final, the American Chemical Society standardized final. Now, you will be given a booklet, and I'll talk about that in a second. And it's a Scantron card you'll mark, and you will do the first 60 questions. There's more questions in the booklet, but you only do the first 60. Now, this is a timed exam. You'll only have 55 minutes. Yes, I have no control over this. And it covers all the material I talked about this semester. Now, for a Scantron, you need either a number 2 pencil or a hard lead pencil. Like my favorite, I've been using this one since somewhere circa about 1987. It's that good of one. I've got a couple backup that I never had to use. But also, like I said, bring a good eraser. Since you're taking it at the Glen Ellen Testing Center, you'll need a picture ID, and per departmental rules, you need a scientific non-programmable calculator like this one. The ones that you can graph on, we don't allow, because they found years ago students could put stuff in there to help them cheat. And that's why we stopped having students use that. All right. Now, this is very important. For the ACS exam, you only do the first section. That's the first 60 questions. You'll have a 55-minute time limit. I already talked about the calculator and pencil. Now, this is very important. And they should tell you this also at the testing center, because I put these instructions in for them to tell you, but I'm telling you now. On the Scantron card, print, you don't have to sign, print your name, my name, the instructor, Dr. K. White or Dr. White, and the class, which is CHEMI 1211 net 02. You need to write that on the front of the card at the top where it has name and other stuff. Again, print your name, my name, Dr. White. I think I'm the only Dr. White in the chem department, and maybe in the whole school. And then the course name, which is CHEMI 1211, and it's important to put the section NET02. Now, since we reuse these booklets over every year, they have a couple different versions they can give out. Please do not write or make any marks in the ACS final exam test booklet. If you do, the chem department chairpersons yells pretty hard at faculty members. Therefore, I reserve the right to subtract up to 50 points from your total points for this class for anybody who writes or marks anything in the final exam book. So don't write in the final exam book. You will be given scratch paper, and you'll also be given a periodic table, just like you will for my test too. Now, if you do find any marks or writing in the booklet, after you finish the exam, inform the testing center staff that you found that, so they can make sure that you don't get blamed for the marks or writing in the book. All right, how to prepare for test 2. Very simple. Use your, let me click something off that popped on my screen. Use your quiz 1, 2, test number 1, quiz 3, 4, how do you like these special effects, 5, and 6 to study. Use those as your practice problems. I sent out not too long ago a blank copy of test number 1 because there was no way I could get test number 1 back to you. And I also provided in that email a link to the answers for test 1. Now, I'd highly recommend all of you go through test 1 again. Why? Because a lot of you did badly on test 1. And where you did badly were on mole problems and balanced chemical equations. And the 3-part mole problem that was in that test. So what I'd like to do now is just remind you now, one other thing I do want to point out, if you go to the lecture folder of Blackboard, you'll see a file called Final Exam Important Information. These are the key formulas and information, not all, but most you should know for my test number 2 and the ACS final. One is the formulas for converting temperature. The other is the electron configuration, shells and subshells, and how to do that. Now, this is where you had a lot of problems, and you shouldn't go back and do the problems or look at test 1 and also chapter 6 and 8, and I'll show you that in a second, for these concepts. 1 mole of an element equals Avogadro's number, 6.02 times 10 to the 23rd atoms of that element. 1 mole of a compound equals Avogadro's number of molecules of that compound. 1 mole of an element equals the atomic weight of that element in grams, and 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight is the sum of all atomic weights. Now, one where a lot of you had problems was this mass calculation for reactions. And I'm going to go through test 1 again, that problem. Now, when it came to solutions molarity, you people did quite well on that. But go back and review quiz 3. Also, Boyle's law. Well, molarity was, I take it back, on quiz 4, which you all did good on. And quiz 3 was gases. And remember Boyle's law? And my favorite, the ideal gas law. Now, I haven't started grading because the deadline is 11:30 tonight, but for quiz 6, remember a Bronsted-Lowry acid is a proton donor, and a Bronsted-Lowry base is a proton acceptor. Remember the pH scale. pH is minus the log of the hydronium ion concentration. Here is my gift to you. If the hydronium ion concentration is 1.0 times 10 to the minus x, then the pH is x. Now, in the ACS, you might have to use the logarithm function on here. If I can find it. reading glasses. Since I rarely use it, I can't see it right off. It's on here, look for it, but for my test, you won't need that. All right, remember the ionization constant Kw is equal to hydronium ion times hydroxide, and that's equal to 1.0 times 10 to the minus 4. Remember for titrations at neutralization, moles of acid equal moles of base. Therefore, milliliters of acid times molarity equals milliliters of base times molarity. Now, my test two, my questions are straightforward, and therefore they won't be multiple. I think what I say, 3 or 4 multiple choice, but most of them are like you saw in the quizzes in test one. However, the ACS final is multiple choice. Now, everybody take a deep breath. Let it out. Take a deep breath. Let it out. Are you hopefully nice and relaxed? The last time I checked a couple of years ago, and I don't think it's changed much, the US average for that ACS 1211 type final, out of 60 questions, the average was about 28, 27. Yeah, it's that bad of a test. If I gave a test where the average was less than 50%, I would think A, I didn't teach well, B, I wrote an awful test. Probably more B, and I don't. So here's some advice for the ACS final. 1, do all the problems, the first 60, that you don't have to calculate anything. Do all the problems where you do not need a calculator. Then go back and do the ones where you have to spend more time, because you got only 55 minutes. The other thing, when there's about 5 minutes left and you haven't answered some questions, I hate to do this, but it's for this test, it's probably the best advice. Guess. Don't leave any answers blank. You don't get penalized for a wrong answer. I actually took in grad school, or was it the GREs? GREs are like the SATs, but to get into grad school. And there, if you got the no answer, you got so many points or taken off. And if you got the wrong answer, you got more points or something. It was an awful test. But I did get to grad school, so I must have done good. But guess, if you're running out of time, start multiple guess and fill in the answers. Now, one of the things for multiple choice I've done in the past is look at the answers. Usually, most of them, there's something going to be out of place, and only one will be it. One way to look at it is check units. If you're asked for a volume in liters and they give you milliliters or whatever, well, that might be a key, or other things. Now, one thing I haven't done is sometimes when they'll do electron configuration answer, they'll have the core like helium, and they'll put that in a bracket, and then the last couple electrons. They won't show all of them like I have asked you. So I know some of you have learned that. That's one difference. The other thing, everything I taught you, you should be able to do on the ACS. But good news is, which is why I tell you to take it second, not before my test two, it's only worth about 5.2% of your grades. And I curve it heavily. So it usually, unless you're on border between two grades, the ACS really doesn't hurt or help your grade. All right, what I'd like to do now is let me open up something. This is in a video, the link I sent you the email with you got a blank copy of this test. What I highly recommend a lot of you do is look at problems 15, 16, also 17. Remember how to balance equations. Remember, do hydrogen, oxygen last. And 20. Let's go through these again and also look at problem sets 6 and 8, chapter 6 and 8, to see how to do these. Let's look at 15, 6 points. How many moles of potassium chloride, KCl, are in 8.304 times 10 to the 44th molecules of KCl? Now remember, for the ACS, don't write in a booklet. On my test, you write on there. And you're trying to find moles of KCl. You're given the molecules. This is the only number we have to start with. This is the units we're trying to get to. How do you do that? You have a ratio that you convert molecules to moles. What's on top of the ratio? Whatever units you're trying to get to. What's underneath the ratio? Whatever units you're trying to get rid of. Because remember, anything divided by itself is the number 1. So molecules divided by molecules become 1. You're left with just the units moles. And that's an important check you should do on my test too. And where do we get this relationship? 1 mole of a molecule equals Avogadro's number, 6.02 times 10 to the 23rd molecules. 1 mole, Avogadro's number. And that was one of the things I told you to know from important information, excuse me, final exam. And then you do the math for significant exact number 3, and my answer is 3 significant figures. And a lot of you set that up upside down or just were lost. Practice those from chapter 6. And I'll show you those in a second. Let's look at 16. How many moles of oxygen gas, O2, are in a sample of 0.444 grams of oxygen gas? Again, what are we trying to find? Moles of O2. What are we given? A weight. Therefore, the only thing we have to start with is this weight. We're trying to get the units of our answer to be moles of O2. And if we have a ratio that we can convert grams to moles, what goes on top of that ratio? The units you're trying to get to. This is using your good buddy, your good friend, unit analysis. That's moles of O2. What are we trying to get rid of? Grams. So we put the grams of O2 underneath, because grams divided by grams becomes the number 1. I like those special effects. I'm ambidextrous. Anyways, and it cancels out. You're left with moles. Now, what's the relationship of a mole to weight? 1 mole of a compound equals the molecular weight of that compound in grams. And that's not important information, final exam. 1 mole of a compound equals the molecular weight in grams. And the molecular weight of oxygen gas is the sum of all atomic weights. And now if we look at the periodic table, underneath the chemical symbol O for oxygen, we have 15.999. That's the atomic weight. Round that off to three significant figures, you get 16.0. Remember, the atomic number is the number of protons and electrons, which we're not using for this problem. So 2 oxygen, 2 times 16.0, 32.0. Put that in there. Notice grams cancel out grams of O2. We're left with moles of O2. 3 significant. The 1 is an exact number. It's part of definition. And 32.0 is 3 significant figures. And we get this number, which is 1.39 times 10 to the minus 2 moles. Now, if you look at chapter 6, practice problems, I have a whole lot more of these same type of problems if you need to look at more of them. Like here, how many moles are 9.008 times 10 to the 56 molecules of nitrogen? How many moles are 34.56 grams of water? Again, you should know how to do these problems for my test too. Hint. All right, let's move on to another problem in test 1 that a lot of you had trouble with. That's number 20. 10 points. Know how to do this. Just like you knew how to do the ideal gas law. That was 15 points. You did a good job on that. I was very proud of all of you. All right. Number 20. How many grams of hydrogen gas, H2, are needed to react with an excess of nitrogen gas, N2, to make 85.9 grams of ammonia? And you're given a balanced chemical equation. Remember, the coefficients, the number in front, tells you how many moles, the relationship of moles. And what that tells me is 3 moles of hydrogen react with, when there's no number, it's number 1 mole of nitrogen to make 2 moles of ammonia, NH3. Now, here we're trying to go and find how many grams of hydrogen. The only thing we're given is this weight of ammonia, NH3, and this balanced chemical equation. And if you look at important information, final exam, here we have mass calculation for reactions. Mass means grams. And there's 3 steps. Step 1, convert the mass of whatever you're given, A, to moles of A. Then step 2, convert the moles of A, whatever you just figured out, to moles of the molecule you're trying to find, B. And finally, because you're asked to find grams, convert moles of B to grams of B. And let's look how we do that from test number 1. All right, so we're trying to find grams of hydrogen. We're given grams of ammonia. Whatever we're given grams, we convert to moles. So we have these many grams of ammonia. We're trying to get the moles of ammonia. If we have this ratio, whatever we're trying to get to, the units go on top, moles of ammonia. Whatever we're trying to get rid of, the units go underneath, grams of ammonia. Where do we find a relationship of moles to weight of a compound? 1 mole equals the molecular weight of that compound. And the molecular weight is the sum of all atomic weights, which is 1 nitrogen, NH3, 3 hydrogens. Nitrogen has atomic weight of 14.0, hydrogen 1.01. Let's review from our periodic table. Hydrogen 1.008, round that off to 3 significant figures, 1.01. Nitrogen 14.007, round that off to 3 significant figures, 14.0. So we add it up. Remember, when you're adding, you get the same number of significant figures to the right. This is left, this is right, to the right of the decimal. I like these special effects I'm pulling out tonight. My decimal fist to the right of the decimal. I shouldn't have done that. Yeah, Dr. Oh, that was lame. But my decimal fist to the right of the decimal, you get the same number of significant figures to the right of the decimal for addition as the number with the fewest. This is 1, 2, keep the 0, drop the 3 because that's 4 left. So the molecular weight of ammonia is 17.0. And now we do the math and you get 5.05 moles of ammonia. Second step, whatever we just figured the moles of, we go and calculate the moles of what we're trying to find, hydrogen. Moles of A to moles of B. So we have these many moles of ammonia. We're trying to get to moles of a hydrogen. We have a ratio to convert it using your good friend, your good buddy, unit analysis. Whatever we're trying to get to goes on top, moles of H2. Whatever we're trying to get rid of goes underneath, moles of ammonia. And where do we get the relationship of moles of hydrogen to moles of ammonia? From the balanced chemical equation. The coefficient, the number in front, tells me here, for every 3 moles of hydrogen, H2, I make 2 moles of ammonia, NH3. Again, for every 3 moles of H2 hydrogen, I make 2 moles of ammonia. So here I have 3 moles of hydrogen per 2 moles of ammonia. Coefficients from a balanced chemical equation are exact numbers. So this is 3, exact 3. Are we done? No. We're trying to get the grams of hydrogen. Now we do step 3. Moles of B to grams of B. In this case, B is what we're trying to get to the molecule, hydrogen. So we go from moles of hydrogen to grams of hydrogen. And here we have from step 2, 7.58 moles of hydrogen. We're trying to get the grams of hydrogen. If we have a converting ratio, what goes on top? The units we're trying to get to, grams of hydrogen. What goes underneath? The units we want to get rid of, moles of hydrogen. And where do we get a relationship between moles of a compound and grams of a compound? 1 mole equals the molecular weight of a compound. 1 mole of a compound equals its molecular weight, and the molecular weight is the sum of all atomic weights. Well, there's 2 hydrogens, 2 times hydrogen, the atomic weight of hydrogen, the 3 significant figures, 1.02, and that becomes 2.02, which is here. Moles cancel out, and we're left with grams of hydrogen. The reason I'm going through this one, especially 20, on test 1, a lot of you did poorly. I mean, poorly. Hint, know how to do this. I'll be subtle. Hint, know how to do this. Now, let me remind you, if you need more practice, for just moles conversion or molecule conversion, 1 step, chapter 6, practice problems. And here are the answers. For the type of problems I just went through, for that 10-point number 20, example number 5 is an example of that, number 4, and number 3. Those are all problems you should know how to do. Again, use your quizzes, and test number 1, which I sent you a blank copy, and I sent you a link to the answers that I went through in a video for practice problems for my test 2, and they'll do a really good job for the ACS. Let me remind you, take test 2 and the ACS at the same time. You have to get them done by Wednesday. After that, if you haven't done it by Wednesday, unless you had a medical emergency, you'll get a 0 for both, because it's the end of the semester and I have to get my grades in. So I highly recommend you take my test 2 and the ACS final exam at the same time. Take it either Saturday tomorrow or Monday or Tuesday. Don't wait till Wednesday. It's going to be swamped in there really bad, and that's the deadline. So with that, that's my advice. Remember, for the ACS, do the problems where you don't have to calculate, then go back and do those. And if you're running out of time, just start guessing. I hate to say that. I hate to say that, because on my tests, before ACS, when I gave a 12-11 final, there are very few multiple choice. You have to do like on test 1 and 2 or the quizzes. But that's not my ability to control. With that, I'm done. I'm going to stick around and answer any questions if anybody has any after I'm done and shut off the recording. And like I said, I'm retiring after this class from COD, from teaching. I'll still be doing research and other things in chemistry. I'm not going to give her that up, no, but doing consulting. But teaching-wise, it's been fun. I hope you enjoyed this semester. If you like what I did, go to ratemyprofessor.com and let people know. If you really liked what I did, and I'll send this out in email, send the president of COD an email that I did good, and the chairman of the board of trustees. I'll send this out in an email. And with that, end of the semester, goodbye. Gehen gesund, and you've learned that means go in health in Yiddish. I started doing that when we went to Zoom and COVID, and it was pretty nasty. If you remember, back in 2020 and 21, people were dying in Illinois and elsewhere. Luckily, I never had any of my students die. Some of them had COVID and got sick, but we're able to recover, thank God. And with that, I'll say gang gesund, and you know what's coming now. Yep. Bye now. Bye. Stole that from Granny to Beverly Hillbillies. Bye.